Okay, so in this video, we're going to start notes for 3.2, and this is called 3.2, the periodic table. We're going to start talking more about chemistry stuff in this unit. And so you should definitely have a copy of your periodic table. You should have hopefully received your Unit 3.2 notes to fill in. And if not, you should hopefully be able to get them from the IPC bin near the front of the room. Same thing with the periodic table. If you don't have one of those or if you needed another one, please make sure that you get that from the IPC bin. You should be able to find both of those things near the front of that bin. Okay, again, it's the Unit 3.2 notes in the periodic table. And if you have them, also get different colored pens or pencils to color in your periodic table, which we'll be doing here in a few minutes. Now, if you don't have different colored pens or pencils, that's okay. You can use a regular pen or pencil and just shade in differently for different parts of the periodic table. Okay, and so make sure you pause it here and make sure you have all those things before you continue on in the notes. Okay, also make sure that as you go through this video, you're answering all of the questions using your notes. Make sure you're filling in the blanks for your notes. Make sure that you know how to access this presentation. This Google Slides presentation, you can access through Canvas. And so if you go into Canvas under modules, at the top of the module for this unit, you should be able to find a link to the Unit 3.2 notes. You might need to scroll down to one of the later slides until you find where it says Unit 3.2, because all of the notes from our last unit are also in the same Google Slides presentation. And so you might need to scroll down a while before you find this set of notes. It should start around slide 89. Okay, and so if you need to do that as you go through, then please have that presentation open as you watch this video and use your notes to answer the questions. Okay, remember the questions in this Edpencil video are going to be part of your formative grade, and please do your best to answer the questions correctly. Okay, so the first thing we're going to do is we're going to talk about what the periodic table is. Now, we've actually been using the periodic table in 3.1 when we talked about the atom. Basically, the periodic table lists all the known elements in the universe, along with some important information about them. And we actually saw that in the last video, sorry, not in the last video, in the last unit, when we talked about the atom. We learned about, chemical symbols. We learned that the top number above the chemical symbol on the periodic table is the atomic number, which tells us how many protons that atom has in its nucleus. We can also find the atomic mass on there as well. And so the periodic table lists a lot of different important information about all of the elements that we know about in the universe. But what you might not know is that it's actually arranged in a very specific way that we're going to talk more about in this unit. And so before we start this unit, I want you to watch this short video about the history of the periodic table. And so make sure you have your earbuds in or your headphones in so that you're not disturbing others as you watch this video. And then go ahead and click on the link that I'll put up in just a minute. Okay, so hopefully you found that video interesting and helpful. But let's take a look at the periodic table. Now, the very first thing we're going to look at is how the periodic table is organized. And it's actually organized in a way, um, it's actually organized in a very specific way, because when they were discovering new elements in the 1600s and 1700s and 1800s, what they actually discovered is that some elements, some types of atoms actually like behave in a similar way to other types of elements. And so based off of that, but based off of those similarities, we can actually arrange the atoms, we can arrange the elements into what's called groups. And so if you look at your periodic table, the columns are what's called groups. And so on the slide that you see in front of you, you can't see any chemical symbols, but this one in the top left would be helium, and the one underneath it would be lithium, and then sodium, and then potassium, and then so on. Okay, and so what I want you to do, first of all, is I want you to label on your periodic table the different groups. So you have group 1, you have group 2, group 3, group 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, all the way to group 18. Okay, and so I want you to label the different groups on your periodic table. Go ahead and pause the video and do that now. Okay, so there's 18 different groups in the periodic table, and the similarities between different elements within each group are why they are organized the way they are. And so what they actually discovered is that elements in group 1 all behave in a similar way under similar circumstances. And the same thing with the elements in group 2 and so on and so forth. Okay, and so what we're going to talk about now is different ways to classify elements. Notice by the way what it says here in the notes that the periodic table is arranged by increasing atomic number. And so the atomic number starts with 1 with hydrogen, and then hydrogen, helium, lithium, and so on and so forth. Okay, but elements in the same group, that is the same columns, are going to act the same as other elements in that group. Okay, so the first thing I want you to either color in or shade in on your periodic table is this. Okay, and so most of the elements on the periodic table are made up of what's called metals. Okay, and so all of the yellow boxes on your periodic table, I want you to use a different color or use a different type of shading. It doesn't have to be yellow, but just some way so that when you look at the periodic table, you can immediately identify the metals on your periodic table. Okay, and so those are going to be most everything in groups 1 through 12. When you get to group 13, you're going to kind of leave this top box uncolored. Basically everything white on here you're not going to color in yet. Okay, so go ahead, pause it here and color in the metals on your periodic table. Okay, so before we move on, I do want to tell you about a certain type of metal. Besides hydrogen, the elements in group 1 are called alkali metals. And so just to go back for just a second, when I say group 1, of course what I'm talking about is I'm talking about this group over here. And so these right here that I'm drawing the box around, these are called alkali metals. Okay, and the reason I want to talk to you about alkali metals is because they have kind of cool reactions in water that we're going to take a look at here in just a minute. Okay, so these are the alkali metals. Okay, and there's different ones. There's sodium, there's potassium, cesium, I think lithium is one of them, and they're all very, very reactive in water. Okay, and so what I'm going to do is I'm going to link 2 or 3 videos of demonstrations involving putting these alkali metals into water, and you can see how they react. I think it's kind of cool to see. So hopefully you enjoy that, and then later we'll talk more about why are these alkali metals so reactive. Okay, so you're going to pause it here and you're going to watch these videos about alkali metals and then answer some questions. Okay, so hopefully you enjoyed those videos. Before we move on from metals, I want to talk to you about some properties of metals. Okay, so metals tend to be shiny. Now, most people know what shiny means. They also tend to be what's called malleable. And if you don't know what malleable means bendable. It means it's easy to kind of bend it. So if you imagine like a piece of aluminum foil that's really easy to bend and crinkle up. Or gold or silver are also malleable. That's why we can make rings and jewelry out of like gold because they're malleable. And so metals tend to be malleable, meaning bendable. They also tend to be good conductors of heat and electricity. And so what that means is we can use them for example, cookware. If you think like pots and pans that you have at home tend to be made out of metal because those are good conductors of heat. Okay, they're also good conductors of electricity. This is why you can't stick like a metal fork into an outlet because you get electrocuted. This is also why, for example, we use like copper wires in the walls. That's how we use most of our electricity wiring is made of copper because copper is a metal and that is a good conductor of electricity. And then finally, another property of metal is that they are usually solid at room temperature. The exception to that would be mercury. Um, I don't know if you've ever used a mercury thermometer before, but it's the thermometer that you put under your tongue when you're sick, and it's got like a little liquid metal in there and like a red line. And if you have a fever, then the metal goes up and indicates that you have a fever. Okay, and so that is an example of a metal that is a liquid at room temperature, but most metals are solid at room temperature. Okay, so now we're going to answer some questions in your Edpuzzle video using your notes. Okay, so let's see if we can answer this question. Okay, so example, a scientist studies a sample of an unknown material. Which one of the following observations would lead the scientist to believe the sample might not be a metal? Okay, look at that word might not be. So A says it is easy to bend the sample. B says it is a solid. C says it is a poor conductor of electricity, and D says it is shiny. So which of the following observations would make a scientist think that this sample is not a metal? Okay, so try to answer that question on your own. Okay, so the correct answer should be C. A, B, and D are all properties of metals, but C is not because metals are actually a good conductor of electricity, not a poor conductor of electricity. All right, so hopefully you got that correct. And now we can move on in our notes. Here is the next thing that you're going to color in on your periodic table. Okay, and so pause it here if you need to color in or shade in this part of your periodic table. Again, everything that's in white you're ignoring or you've already colored in for now, but everything that's in blue, you're going to use a different color or a different type of shading that you did before. And so go ahead and do that now. This is going to be nonmetals. Okay, so nonmetals tend to be in groups 17 and 18, okay, but they're also in some of the other groups. And here are some properties of nonmetals. Okay, and a lot of the nonmetals that you see on the periodic table are actually gases, right? So like, for example, hydrogen, helium, neon, oxygen, those are all gases. And so properties of nonmetals, they're not shiny. If they're a solid, which some of them are gases, but if they are a solid, they tend to be dull. They tend to be brittle, which means they break easily, and they are not a good conductor of heat and electricity. In fact, they're usually liquid or gas at room temperature. And I do want you to know about the last two groups on the periodic table, group 17, which is right here. This group is what's called the halogens. Okay, these are a very reactive type of nonmetal that we'll see in some videos here in a bit. And then group 18, that's the very last column on the periodic table. These are what's called noble gases, and these gases are non-reactive. They do not react very easily. They're very what's called inert. Okay, they don't react. And again, I'm talking about the group 18, the noble gases. That's like helium and neon and stuff like that. They're very non-reactive. Most people, when you see the word noble, you think like kings and queens. I'm not really sure why we call these noble gases, but those are the non-reactive gases versus the halogens, which are right next to them in group 17, which tend to be very reactive. Okay, and so pause there and make sure you have that in your notes before you continue on. Okay, so next example, and again, make sure that you're answering this question using your notes. Try to answer it correctly, but also make sure that as I go through the correct answer that you're also circling that in your handout notes. Okay, so this question says, use your periodic table to answer the following question. Which of the following is an example of a non-metal? Okay, so based off of how you should have shaded your periodic table or colored your periodic table, which of the following is not a metal? Okay, so pause it there and try to answer the question. Okay, so just based off of your shading, hopefully you saw that the only non-metal on this list is going to be oxygen. Sodium, aluminum, calcium are all on the left side of the periodic table, and so those are all going to be metals. Oxygen, you should know oxygen is a gas, that's not a metal, right? And so, plus it's on the right side of the periodic table anyway. Okay, so oxygen is a non-metal. Hopefully you got that answer correct. Okay, next question. Which of the following is not an example of a noble gas? And so if you look in your notes, you should be able to see what I talked about when I talked about noble gases. And then you should be able to look at your periodic table to identify which of the following is not an example of a noble gas. Okay, so pause it here and try to answer that question. Okay, so the only example of that's not a noble gas is going to be D, which is chlorine. Noble gases, remember, you're looking at group 18 on the periodic table, that far right column of the periodic table, and helium, neon, and argon are all in group 18 except for chlorine. Chlorine is not in group 18. Actually, I believe it's in group 17 if I'm not mistaken, which would make it a halogen. Okay, so hopefully you got that question correct. Okay, and then finally, the last thing you're going to color in your periodic table are what's called metalloids. Okay, this is kind of along the staircase here on the periodic table. So this is where you would use like a third color or a third type of shading. So go ahead and pause it here and do that now. Okay, and so a metalloid is basically something that could either have some properties of a metal and some properties of a non-metal, and it's not really consistent. And so the metalloids would be like boron, silicon, germanium, and so on that you can see on this list here. Okay, so you should now have a fully colored in periodic table with the metals, the nonmetals, and the metalloids. Okay, and so here is the full periodic table. There are some special groups that you need to know. We already talked about the alkali metals. That's over here in group A, or sorry, in group 1. Group 2 are called the alkaline earth metals, if you want to label that on your periodic table. Group 17 are called the halogens. Remember, those are the reactive nonmetals. And then group 18 are called the noble gases. Okay, and so those are the ones that you should be most familiar with from the periodic table. Okay, so go ahead and make sure that those are labeled on your periodic table before we move on. Okay, and then the very last thing we're going to do in this video is we're going to watch a few videos about the halogens, and we're going to see how they can react and the cool kinds of reactions they can have. And then later in the next video, we'll talk more about why do they react the way they do. Okay, so please let me know if you have any questions. Please rewatch this video if you need to, and make sure that you're filling in your notes as you go. And remember that you can always access this presentation through Canvas, and you can always reach out to me if you have any questions about anything in the notes or about anything in the class. Okay, so as always, please let me know if you have any questions, and I will see you guys in the next video.